I'm going to review a couple of Euclid's proofs, and this is very important for Euclid Book 2, proposition number 8. Now, we're not going to cover Euclid Book 2, proposition number 8 in this video, but in the next one we will. And you have to know all this before we go ahead and cover that one. Okay, first of all, do you remember Euclid Book 1, proposition number 48? Okay, we had a little problem, because when we drew the triangle A here, B here, C here, we did not know if this angle right here was a right angle. But, according to Euclid Book 1, proposition number 11, we did know that if we had extended AC out like this, we could draw a perpendicular to AC called AD, and it would be a right angle. Now, if we went on with the proof after that, we could then say, because Euclid wanted us to draw a line that from A to D that was equal in size to line AB, then we could go on to say that the square underneath AD and the square underneath AB were exactly the same size. Okay? So, if we added the square here plus the square here, we get the square here. That's Euclid Book 1, proposition number 47. And since we were saying that the square here plus the square here was going to be equal to the square here by the hypothesis, then we could go on with the rest of the Euclid proof, and that would prove Euclid Book 1, proposition number 48. Alright, now we need to go back to Euclid Book 2, proposition number 4, and show you something very important. Now, in order to show you this important thing, we have to go back to Euclid Book 1, proposition number 29. Euclid Book 1, proposition number 29. The first thing we have to say is that angle EGB is equal in size to angle GHD. GHD. These two angles are equal in size. Okay? Then we can go on to say that angle AGH is equal in size to GHD. These two angles are equal. These two angles are equal. These two angles are equal. Then we can go on to say that angle CHF, which now we'll find CHF, this one right here, is equal in size to GHD. Why are these two angles equal? Well, if you'll remember from a previous Euclid proof, alternate angles, when you have two lines cutting each other, are equal. Okay? So, now we can say that AGF here is equal in size to CHF. These two angles are equal in size. Alright, so how does this apply to Euclid Book 2, proposition number 4? Well, this not only applies to proposition number 4, but it also applies to number 5, number 6, and number 7, because we were having a tough time. Let me show you the tough time we were having. We knew this was a square, and we knew these two were rectangles, but we needed to prove that this one was also a square. Well, how do we do that? Well, because of what we just showed you on Euclid Book 1, proposition number 29, then we can say that angle ABD is equal in size to angle HGD. Okay? And we already know that angle ABD is equal in size to ADB. These two angles are equal. So therefore, if these two angles are equal and these two angles are equal, then we can say that HGD equals HDG. And because of that, because these angles are equal, then these two sides are going to be equal, like that. And we could go on and on and on, yada yada yada, just like we did up here. And by doing so, we can actually prove that all of this is a square. And we could do this by Euclid Book 1, proposition number 34, because then that makes HG equal to DF and HD equal to GF, and we've already established that these two are equal, so therefore yada yada yada, the whole thing is a square, etc. And that's where our problems were coming from. This is all going to be very important to Euclid Book 2 proposition number 8, because we've got a lot of squares that we're going to have to come up with. And you needed to know all this before we came up with all this square business. Alright, I will cover Euclid Book 2 proposition number 8 in my next video, so stay tuned.